Okay, now we're going to talk about standard temperature and pressure and how that relates to the molar volume of a gas. So we can first look at our ideal gas equation. PV equals nRT. And as we just talked about, in standard temperature and pressure, the temperature and the pressure are always the same. So we can then plug those values into this equation and determine the numeric relationship between volume and moles of an ideal gas. Okay, go ahead and watch. I think this will make more sense. So we are going to rearrange our equation so that volume and moles are on the same side. So we're going to divide both sides by P. Volume equals nRT over P. And now we're going to divide both sides by N. And we end up with volume over N equals R times T over pressure. So now we've written out the equation that helps us see the relationship between volume and moles of an ideal gas. Now remember, R is a constant, T is a constant at STP, and so is pressure. So we can now plug in the values for R and temperature and pressure and calculate the numerical relationship between volume and moles. So let's go ahead and do that. Our R is 0.082058 liter atmospheres per K mole. Temperature is 273.15 Kelvin. Pressure is 1 atmosphere. So now we can get out our calculator, multiply 0.082058 times 273.15, and we find that volume over N equals 22.4 liters per mole. Okay, so you're going to see that we now can actually use this number to help make things a little bit easier for us. And I have written down on your reference sheet this molar volume of an ideal gas. It's on your reference sheet right here. So again, you don't have to remember how to derive it, but I'm going to show you a little shortcut that hopefully will make things easier for you. And again, your molar volume of an ideal gas is shown on your reference sheet. Okay, so now how can we use this molar volume? Let's go back and look at our original equation. What is the volume of 5 moles of an ideal gas at STP? So we already solved this problem earlier using the ideal gas law, but I'm going to show you a shortcut where we can use the molar volume of an ideal gas to make this a little bit quicker. So the relationship of moles to volume of an ideal gas is 22.414 liters per 1 mole. So what we can do is use this number to make a conversion factor. We know that if we have 22.414 liters of gas, that will be 1 mole. Or we can write it the other way. 1 mole of an ideal gas will occupy 22.414 liters. So now we're going to use this conversion factor the same way we used conversion factors before. We're going to write down our starting amount of 5.0 moles. And we're going to multiply it by a conversion factor. We're going to use our first conversion factor so that moles is in the bottom. Okay, our moles is going to cancel out, leaving us with volume. So now we can do 5 times 22.414, and we get an answer of 112.07 liters. Again, we want to round our answer. We started with 2 significant figures, so we can round this answer to 2 significant figures. We've got our answer 110 liters using the molar volume of the gas. Now I'm going to go back and show you the first time we solved the equation using the ideal gas law, and you'll see that we also got 110 liters. So you can pick whichever way is easier for you. You can either use the ideal gas equation, or you can use the molar volume of an ideal gas, which I have included on your reference sheet for you right here.